Hello dear students, so we continue with our learning about alcohols. We've been dealing with the preparation of alcohols with the help of this flow chart, and till now we've already covered the preparation of alcohols using alkenes, 4 methods under that. We have also covered haloalkanes, aldehydes and ketones. What are we going to do today? We're going to continue with our learning of preparation of alcohols using carboxylic acids and esters, acyl chlorides and primary amines. Are you ready with your pen and paper to continue with your learning about the topic, because it's your own writing which is going to get you through this topic and not just the video alone. So if you haven't, please grab a pen and paper. Carboxylic acids to alcohols. Now, if you remember in the previous video, I had told you the flow of oxidation and reduction products in any chemical reaction. So, we have alcohols on oxidation turn to aldehydes. Aldehydes on oxidation give us carboxylic acids. So, what if we have to go the reverse pathway? So if we want to convert carboxylic acids to aldehydes, yes, of course, we reduce. Aldehydes to alcohols is again a reduction. So can you tell me, how do we convert carboxylic acids to alcohols? My God, it's a big reduction that I will have to carry out the reverse, right? Carboxylic acids to alcohols means I have to reduce in 2 steps. I need a strong oxidizing agent over here. So that strong oxidizing agent possible is only lithium aluminium hydride, which in short I have written it as LAH. You can also write it as Li. So remember the L capital I small a L, H and 4 over here. So lithium aluminium hydride, and of course followed by hydrolysis, gives you alcohol. So would you like to write the products of the reaction yourself? Are CH2OH. You get an alcohol over here. So I've given you an example. So R is when we take a general acid, a general carboxylic acid. What will be the product of reduction of CH3COOH? By the way, what is the name of this compound? Try naming it by the IUPAC system. Did you name it as methanoic acid? If you've named it as methanoic acid, thinking that there is a CH3 group over here, rethink. You need to rethink. Look at the number of carbon atoms and then tell me what will be the IUPAC name of this compound. Yes, you got it right. There are 2 carbon atoms in this. So CH3COOH. Because of the 2 carbon atoms, it takes the word root eth. Saturated, so ane. Carboxylic acid is the functional group, so oic acid, right? Starts with the vowel, we do away with the vowel and we have ethanoic acid. We avoid 2 vowels together. So if your suffix is ending with A, E, I, O, U and Y, then we do away with the last vowel of it, right? Did you write the products of the reaction? Lithium aluminium hydride followed by hydrolysis, what will you get? So instead of R, I have CH3. See, look at the expanded structure. CH3, C double bond OOH. Reduction. This takes up the electron, hydrogen over here, hydrogen over here. What do I get? This doesn't seem right, correct? Water will be removed because we've got 2 OH groups. But what do we form? CH3, C, double bond O and H. That's an aldehyde. But remember, we are using lithium aluminium hydride, which is a strong reducing agent. So go ahead, reduce it one more step. And what do we get over here? CH3, go ahead, H and H. CH3, CH2, OH. Again, ethanol. I have given you the steps. This is not the mechanism. This is simply an easy way to remember. I repeat, this is not the mechanism. This is just a way to remember how reduction happens. So CH3, CH2, OH is our final product. What will be the IUPAC name of this compound? Again, look at the two carbon atoms. Yes, of course, that will be ethanol. Yes, well done. Good going so far. Now, the problem in this reaction is if you're doing it, on a small scale, it's fine. Lithium aluminium hydride, because it's an expensive reagent. Lithium aluminium hydride being an expensive reagent, we can still use it in the laboratory. We can use it for small scale conversions. But when it comes to on a commercial level, of course, it wouldn't be feasible. So what do we do? What's the way out for this? An easier and better option is to convert the carboxylic acid into a form in which it can be more easily reduced. So what we do is we either convert the carboxylic acid to esters, or we convert the carboxylic acid to acid chlorides, which are much easier to reduce by the cheaper reducing agents as compared to lithium aluminium hydride that we've seen in the previous case. So how do we convert carboxylic acids to esters? Do you remember this? Yes, of course, by the method of esterification, right? Wherein a carboxylic acid is treated with an alcohol to convert to an ester, or we can react it with SOCl2, that is thionyl chloride, in order to give us acid chloride. So let us now go on to the next step, where what we are going to do is we are going to convert esters or acid chlorides to our final product, that is alcohols. Esters to alcohols can be done in two different ways. One is either, as I mentioned earlier, by reduction. The other method that I can use is by using what we call as Grenia's reagent. Yes, my favorite reagents, because you can prepare so many compounds by this method. So, would you like to try the reactions yourself? You know how we did the Grenia's reagent, right? So, go ahead, take any ester and treat it with a Grenia reagent, CH3MgBr. Take the simplest one, because if you remember, we stopped the last video, we ended the last video with this set of reactions only, where we had reacted the aldehydes and the ketones with Grenia's reagent followed by hydrolysis. So why don't you give it a try yourself before I teach you that reaction? So let's go ahead, esters to alcohols using the Grenia's reagent, or Grigna's reagent, right, as we prefer to call it in a lot of the local dialects. Now, R-COOC2H5. Now, I've taken a general formula for the ester, right? R-. So, by the way, if you do not know, esters are compound with the, wherein the hydrogen of the carboxylic acid is replaced by an alkyl group. So, I will have HCOOR. I'll have, instead of H, I can have CH3COOR. We can also have any other alkyl group. So for example, of an ester is C2H5COOCH3. That's one of the esters. So understand the things step by step, and then organic chemistry is a lot easier. It's not as tough as it becomes, when we don't write. We try to understand only by looking at videos and looking at texts. Believe me, it's not going to work. As long as I was just reading the text, I was like this all the time, wondering how to study this. As soon as I picked up a pen and paper and started writing the things myself, this is what it is. So sharing my experience. Do share your experience about learning organic chemistry or any tips and tricks that you may have for other learners. And where will you share it on? Yes, of course. You will share it on pen and paper chemistry on YouTube. So let's talk about reconversion of esters to alcohols by using Grenia's reagent, and of course this is followed by hydrolysis in an acidic medium. So I'm going to take a general ester over here, RC double bond O C2H5. Would you like to take that? Okay. And then we have the Grenia's reagent. I'm taking the simplest one, CH3MgBr. And what is the reaction condition? Don't forget the dry ether. Remember, we mentioned in the last video as well. Now look at the shift of the electrons, negative, and then this becomes positive, right? Whereas for the Grenia's reagent, we have negative here and a positive here. Magnesium is electropositive. So negative attaches to the positive and negative attaches to the positive. So how do we write the products? R, C. Yes, first you can watch and then you can write it yourself as well. CH3OC2H5. Right. Now, if you see, this has become very heavy loaded. Poor carbon is loaded with an alkyl here, an alkyl here, an alkoxy here, and OMG, oh my God, so much load. We need to help it offload. Let's help it out, and there we go. It releases the MgBrOC2H5. MgBrOC2H5. What are we left with? Let's see. Start writing from here. R, C. So of course the electrons of the oxygen now, because they are no longer bonded to magnesium, where will they go? Yes, it is going to share the electrons with the carbon. So we will have over here R, C, double bond O, CH3. What product does this look like? Yes, of course, it's a ketone. And do ketones undergo reaction with Grenia's reagent? Yes, they do. Correct? So let's get writing the reaction of this ketone with Grenia's reagent. So CH3MgBr. I leave it to you to complete this reaction. Yes. I'm assuming you have paused the video and you're writing the reaction. That's why I'm keeping quiet. Try it. Okay. And what is the condition of this reaction? Dry ether. Yes. So again, shift the electrons, negative, positive. And here this will be negative, positive. Correct. So what do? The negative to the positive and the positive to the negative. That's where we go. Come on, form the addition product and carry out the hydrolysis. I'm going to move it from here, and you can write this reaction horizontally as well. There is no problem in that. So I'll have RCOMGBr CH3, and the second CH3, this one becomes attached here, followed by hydrolysis, H and OH. What do we get? RC CH3 CH3 OH. What is this product? Okay, agreed, it's an alcohol. What type of alcohol is this? Yes, of course, it's a tertiary alcohol. Now, supposing I started with a hydrogen over here instead of an alkyl group. Okay, so there was a hydrogen. So what will be the product? The first step. Now, by the same mechanism, write the reaction yourself. You'll know the product. Yes, don't worry. There is no sound in the video because we are writing the reaction. We are waiting for you to complete the reaction. It's good to try things on your own. What should I do next? Yes, offload the carbon. Go ahead. Next step, what do we get? HC double bond O CH3 plus. Oh, it's interesting. Yes. And then what is this product? What's the first product that you've got? Perfect. It's an aldehyde, right? And do aldehydes react with Grignard's reagent? Yes, they do. Come on. So let's start writing the reaction. CH3, C double bond OH plus again the same Grignard reagent, CH3 MgBr, because if you know we don't separate the Grignard's reagent from the reaction mixture. We add the ester or the compound or the substrate to the reaction flask itself. We don't separate. Can you tell me why? We've discussed this under the videos on Grignard's reagent. I'm following exactly the same steps that I taught you earlier. If you have written the reaction, now can you give me some generalization about the product formed with different esters? So what did you form over here? Look at it. Yes, it's again an alcohol, but what kind of an alcohol is it? Yes, it's a secondary alcohol. Look at the functional group CHOH, right? So this is a secondary alcohol. Now supposing I want to prepare a primary alcohol, do you think that is possible? Is there any way that I can have a primary alcohol using esters? Primary means that instead of this CH3, I will need a hydrogen. Do you think that is possible? So that means instead of this H, I should have, so instead of this CH3, I should have an H. But then if I make this an H, it becomes an aldehyde. HCHO, it no longer remains an S. It's an aldehyde, yeah. So I can have an hydrogen over here. So that means I have a hydrogen over here, but then it no longer remains an ester in the starting material, right? What would it be? It would be an aldehyde, right? Because then I would be starting with HC double bond O and H. That means using esters, I cannot prepare primary alcohols. So if you go back to this chart and see the flow chart that we had made, and we said that esters react with Grenia's reagent followed by hydrolysis to give us alcohols. Esters are formic acid. So HCOOH converted into an ester gives us a secondary alcohol, whereas esters of acids other than formic acid are giving us 3-degree alcohol. So for clarification once again, I have HCOOH is methanoic acid or formic acid. I replace the acidic hydrogen by an alkyl group. So this becomes the ester of formic acid. So this is also the ester of methanoic acid. You react it with the Grenia's reagent followed by hydrolysis, you get a secondary alcohol or a 2-degree alcohol, right? And if you have a carboxylic acid other than formic acid or methanoic acid, you convert it into an ester. So R dash over here, in order to distinguish between the two, RCOO R dash reacted with Grignard's reagent or Grignard's reagent gives us a 3-degree alcohol, or what we call as a tertiary alcohol, right? And remember, it's this R which is going to be incorporated in the alcohol, not this R dash. R dash is going to go away. Clear? Esters can also be converted to alcohols by reduction. What are the reducing agents that we can use? Now we saw that in the case of carboxylic acids, that reduction was turning out to be a little expensive, right? So we converted it into esters because we can use a normal reducing agent. So you have hydrogen in the presence of catalysts like nickel, platinum, palladium, your D block metals, in which case it is known as catalytic hydrogenation. The second possibility is you use sodium and absolute alcohol, which again is more viable commercially, and we call it as the Bouvelt-Blanc reduction. I'm trying my best to pronounce it. Excuse if I do not get the right pronunciation of the word. So we have CH3COO C2H5. Reduce it by any of the reducing agents that we have mentioned, and what do we get? What are the products that we will get? Right, try writing, reducing it. So the double bond O will get converted into OH. So you have CH3 CH2OH plus C2H5OH. Interestingly, we are getting the same alcohol in the example that we have taken. Now look at the flow chart once again. You see esters can be converted to alcohols by another method, which I have not listed in the flow diagram that I drew. So it's acid or alkaline hydrolysis. So there's a third aspect that we can add over here, and that is esters to alcohols by what we call as hydrolysis in an acidic or a basic medium. So let us write down the reactions for that. Esters can be hydrolyzed in an acidic or an alkaline medium. So I have taken the general example RCOOR dash. Everywhere where we are writing R, for the level that we are doing, I'm not talking about really advanced levels. you can replace the R dash by simple alkyl groups. So for example, CH3, or instead of CH3, you could have C2H5. You could write specific examples also. So I'm going to talk about a general reaction over here. So RCOOR dash, this is my ester. This ester on hydrolysis in an acidic medium, what will happen here? It will break down here, H positive, OH negative. So there is a positive, there is a negative. So what will happen? Positive goes to negative and negative goes to positive. Remember the electrons, correct? Yes. So plus and a minus, minus and a plus. Simple way to remember, this is not the mechanism. I am repeating this. So R, C, double bond O, OH. So I'm getting, what is this product? Yes, it's a carboxylic acid. And what will be the second product? R dash OH, which is an alcohol over here, right? Remember, you did in your earlier years that carboxylic acids react with alcohols to form esters. Oh, that means this reaction is reversible, correct? So this reaction does not proceed to completion. So let's see what happens in the case when I'm carrying out hydrolysis in the presence of an alkali. Do I face the same problem? Okay, H positive, OH negative. Okay, withdrawal of electrons, positive, negative over here. So negative, positive, again the same thing. RC double bond OOH and R dash OH. Yes, again we form the carboxylic acid and the alcohol. But interestingly, you are carrying out this reaction in the presence of an alkali. So for example, sodium hydroxide or potassium hydroxide, and acids react with alkalis to form salt and water. So that is where the chain breaks down and RC double bond OO negative Na positive, water is formed over here. In other words, now we don't have carboxylic acid, it has immediately reacted with the base, so we are getting the sodium salt of the carboxylic acid and alcohol. That is what we wanted to produce. Sodium or potassium salts of higher fatty acids. So for example, instead of R, we will have C17H35, a big alkyl group. You know, this is soaps. Sodium stearate, right? So this is an example of a soap molecule. That means I can use this type of an example where I take esters of higher fatty acids and I can convert them into sodium salts of fatty acids, which are called as soaps, right? That means I'm making soap, correct? That is why this reaction in specific terms is known as saponification. Sapon means soap making. That means formation of soap can be done by this particular method. That's the plain logic of it. You take the ester of a higher fatty acid, hydrolyze it in the presence of an alkali or an acid. Alkali. And you get the sodium salt of the higher fatty acid, which is the soap. Hence, alkaline hydrolysis of esters is also called as saponification. That's adding to your knowledge. In case you miss out any of this, I'm going to load the entire slides once this topic is over on the Google site Pen and Paper Chemistry. It's a Google site. If you will Google search pen and paper chemistry, it will lead you to either the YouTube channel or the site. So you can download it from there. There's a lot of material on that site which I've discussed previously as well. So you can take advantage of it. Okay, 2 more reactions to go, and we have to talk about the preparation of alcohols from acid chlorides, right? This can again be done by reduction using lithium aluminium hydride or sodium borohydride and primary amine on treatment with nitrous acid. So we have acid chloride, RC double bond OCl, and what is going to happen? Chlorine is going to take away its electrons, it's electronegative. Oxygen says, I can pull electrons from here. At the same time, he's going to be getting nasty. He says, chlorine pulls it, why not me? So what will we have when reduction happens? H and an H, and we need to replace this chlorine with something. So we have hydrogen over here and we form an alcohol. So supposing I have ethanol chloride. Yes, that's the name of this compound. Why ethanol chloride? There are 2 carbon atoms, 1 and 2. So eth, saturated in, and look at the functional group COCl. So ethane OYL chloride. And as I told you earlier, starting with O, do away with the E, and you have this compound is ethanol chloride. But most of the places you will find it written as acetyl chloride. In the previous video, I explained you the concept that the group CH3CO group, this is acetyl group in the common system. Not in the IUPAC system, it's in the common system. It is acetyl and then chloride, acetyl chloride or ethanol chloride. What do you have to do? You have to write the product which is formed on reduction of ethanol chloride. Write the product. Okay, coming to almost the last of the preparation of alcohols. Properties are yet to go. Primary amines converted to primary alcohols. Very simple method. Amines are basic in nature, so I'm going to treat it with an acid, and the simplest acid we're going to take is nitrous acid. Does this remind you of something? Do you remember the diazonium salts? Yes, we've already covered. Those are also very important synthetic reagents. Diazonium salts. We have prepared diazonium salts using nitrous acid. But we don't get nitrous acid in the laboratory easily. How do we prepare? Sodium nitrite and HCl. So what do we get? Nitrous acid. Let's break it down. I'm going to write this nitrous acid as HONO. HONO. Things become very easy for me. ROH plus nitrogen plus water. Try writing the same reaction RNH2. No, not RNH2. Try writing C2H5NH2 reacted with nitrous acid HONO. How do you form nitrous acid? It is generated in situ, NaNO2 and concentrated HCl. What do we get? Break it down in the same way, HONO. What do you form? C2H5OH plus nitrogen plus water, and there we form ethanol. We complete the preparation of alcohols for our grade 11 and 12 students. So if you are preparing for your A levels, this is what we are aiming for, or grade 11 and 12 of the Asian curriculum. We yet have to do the properties, so stay connected, stay tuned, but at the same time, stay relaxed. The most important thing to do when you are learning something new. See you in the next video.